the one that they have kept for your syllabus is this: Sutherland, Hodgman, polygon clipping, right? Sutherland and Hodgman were the two persons, right, who formed this simple algorithm for clipping the polygon, fine, right? So obviously the name of this polygon clipping came under their names, right? Sutherland, Hodgman, line clipping, right? So what we will be doing in Sutherland Hodgman line clipping is, right, so we will be always trying to find the vertices which are there in the intersection point and inside the clipping area. Okay, right, only what we will do is, right, we will yes, sorry, yes. Yes, see here, this is the example which we took, right? So which I shown, right? This is my clipping window. Okay, right? So this is my clipping window, right? And this is my triangle, right? So Sutherland Hodgman, what they did was, right, so they tried to refer, or they tried to move one by one clipping sites, right? That means they first tried to see, right, if there is any area, right, which is towards the left of the clipping window. If there was any area towards the left of the clipping window, they try to delete that, or they try to remove that. Then they were checking if there is any area which was towards the right of the clipping window. If there is any area towards the right of the clipping window, then that area they deleted, they clipped. Then they checked if there is any area towards the bottom of the clipping window. Yes, here there is area. So if there is any area towards the bottom of the clipping window, then they deleted that, right? Next, they check above the clipping window if there is any area, right? If there was any area above the clipping window, yes, they obviously deleted, right? That means I need to go with the 4 steps, right? First, I need to check whether there is any area towards left side. Yes, in this example, there is this area which is towards the left side of the clipping area, right? Obviously, this gets deleted. Next, I will check if there is any area towards right side, right? Next, I will check is there any area towards bottom. Next, I will check if there is any area towards top. Okay, right? And I will be applying the concepts which they give, right? So that at the end, I will be getting the only the part of the algorithm, the part of my object which is inside the clipping area. Okay, fine, right? So now let us start here. Fine, right? So before starting, right, I need to tell you what are the 4 points that they suggested before I go with the left clipping left. Before I check the left side of the clipping area, before I check the right side of the clipping area, before I check the bottom of the clipping area, and before I check the top of the clipping area, right? See, these are the 4 points that they suggested to us, right? Now let us go through the 4 points, right? So now from this diagram, right, you can easily see here, right, you can easily see here, right, v1 is this, v2 is this. Okay, right, v1 is this, v2 is this, and the intersection point of v1 and v2 to this clipping window, right, I call that as v1 dash. Fine, right? So that means if v1 is this and v2 is this, right, that means, right, my edge is moving from outside of the clipping window to the inside of the clipping window. Agree, right? So if this is v1, if this is v2, and the intersection point I call it as v1 dash, right? That means this is the edge where my vertices or my edge is moving from outside of the clipping window to the inside of the clipping window. Okay, that means I am moving from out to in. Okay, from outside I am moving towards inside of the clipping window, right? When this is the scenario where I am moving, right, towards or from outside to the inside of the clipping window, right, what I will consider is, obviously this v1 I don't require, this much I don't require because this is outside the clipping window. So I consider only v1 dash and v2. Okay, right? So if there is any edge which is moving from outside of the clipping window to the inside of the clipping window. That means if I am moving from out to in, then only consider the intersection point and the second vertices. Only the intersection point and the second vertices. This is the first thing they said, right? Whenever an edge is moving from outside to the inside, consider only the intersection point and the second vertices. This is the first thing that you need to remember. If an edge is moving from outside to inside, then you need to consider only the intersection point and the second vertices. Okay. Now let us come to the second point what we said, right? So if both V1 to V2, right? If I am moving the points from inside to inside only, V1 is also inside, V2 is also inside, right? That means I am moving my edge, or my edge is moving right from inside to inside. When my edge is moving from inside to inside, that is from V1 to V2, you should consider only the second point. Okay, right? You should consider only the second point. First point you should not consider. Okay, from out to in, if it is going, you need to consider the intersection point and the second point. If it is in to in, then you should consider only second point. Okay, now come to the third scenario, right? In the third scenario, right, V1 is here, V2 is here. That means I am moving from inside to outside. In the first part, I was moving from outside to inside, right? In the third scenario, right, I am moving from inside to outside. V1 is here, V2 is here. That means I am moving from inside to outside. Okay, right? If that is the scenario, if my edge is moving from inside to outside, then you should consider, that is, if the movement is from in to out, then you should consider only the intersection point of that. Okay, if it is moving from in to out, what did I consider? I considered only the intersection point of that. Okay, right? Now come to the fourth scenario, right? What is my fourth scenario telling, right? In my fourth scenario, both V1 and V2 are outside only. Okay, right? When I'm moving from out to out, that means when I'm going through this scenario, fourth scenario, where I'm moving from out to out, then you don't consider any points, right? What is the output? I will not consider any points. Okay, right? These are the four scenarios that I need to keep it in mind before I go for the next process, right? If my object is moving from out to in, right, consider the intersection point and the second vertices. If it is in to in, then consider only second vertices. If it is in to out, then consider only the intersection point. If both are out, then don't consider anything. Okay, right? Now keeping these 4 points in mind, right, let us check, right, if any point, let us first check, right, towards the left clipper means, right, so I will check if there is anything towards the left side of my clipping window. This is my clipping window. Okay, if this is my clipping window, left side of my clipping window is this, right? So what I will be checking is, right, so now this is my only I should consider only the left clipping window, and I should check all other points. Okay, right? So now this is my clipping window, this is my clipper, right? That is right. What I am considering, the first clipper is left clipper, right? So this is my first clipper, that is left clipper, right? Now with respect to only this, right, I need to tell whether it is going from in to out, or out to in, or in to in, or out to out, right? Don't consider this clipping area, this clipping region, this clipping region, this clipping region. Only region is now this one. This is the only clipping region, left clipper, right? So now what are my inputs? Edges 1 to 2, 1 to 2, next 2 to 3, this is 2 to 3, next it is 3 to 1. These are my edges. Okay, fine, right? So now if this is the clipping boundary for me, okay, right? So from 1 to 2, right, from 1 to 2 means here I have 1, here I have 2, right? From 1 to 2 means, right, what is that scenario? that scenario, my clipping boundary is this, right? If I consider this clipping boundary, this is outside, all these things are inside. Okay, if this is my clipping boundary now, this is outside and all these things are inside. So now if I take 1 to 2, obviously it is in to in, because this is my boundary, right? If I take 1 to 2, right, so it is in to in, both 1 and 2 are inside the clipping region, because this is my clipping boundary, right? So 1 to 2, it is into in. If it is in to in, right, what should I consider? If it is in to in, right, I should consider the second vertex. So what is the second vertex? If it is from 1 to 2 means second vertex is 2. So I will consider this 2. Okay, fine, right? So now coming to the next edge. Next edge is 2 to 3, right? So what about 2 to 3? Right? So 2 to 3 with respect to left clipper, right? So what is my clipper? My clipper is this left clipper, right? So 2 to 3 means, right? So 2 is here, 3 is here, right? So with respect to my left clipper, this is outside the clipping region and this is inside the clipping region. So that means my object is moving from 2 to 3 means, right? My object is moving from in to out. Correct lah? From 2 to 3 means my object is moving from, my edge is moving from into out with respect to my left clipper, right? So into out means I need to consider only the intersection point. So 2 to 3 means, right, the intersection point, I will name it as 2 dash. So it is 2 dash. Okay. Now come to the third edge, it is 3 comma 1. 3 comma 1 means 3 comma 1. This is 3 comma 1. Okay, this is my clipping boundary, right? So now all these things are outside the clipping boundary, all these things are inside the clipping boundary. So now 3 to 1 means obviously it is moving from out to in. It is moving from out to in, right? So if it is moving from out to in, what should I do? I should consider the intersection point and the second vertex. What is the intersection point from 3 to 1? From 3 to 1, intersection point is 3 dash, right? So it is 3 dash comma 1. Okay, right? So now these are the output of my first stage of my left clipper. Okay, right? So now once I get the output of my first stage, that will be fed as an input to the second stage. Okay, right? So that means the output what I got in the left clipper will be passed as the input to the right clipper. Okay, right? So in the form of edges. How do I form the edges? 2 2 dash. 2 2 dash is one edge. 2 dash 3 dash is one another edge. Next 3 dash 1 is another edge, right? And cyclic form 1 2. 1 2 is another edge, right? If you have 1 2 3 4 4 vertices, right? So 4 edges you will get, right? So 2 2 dash 2 dash 3 dash 3 dash 1, and coming in the cyclic form 1 and 2. 1 and 2 is another edge, right? So now we will apply the right clipping now. Okay, right? So for this right clipping means, right, so right side of my clipping window becomes my boundary now. Okay, this is the boundary now. Right clipper means, right? So outside this I don't have anything. Okay, outside this I don't have anything, right? Outside this is now right clipper means this is my clipper. So outside this I don't have anything. So all the edges are into in only now for me, because I am considering the right clipper. That means this is the right clipper, right side boundary. So this is the right clipper. Fine, right? So now, so all are into in only. 2 2 dash into in means, right, I will be considering second. 2 dash 3 dash into in means this is 3 dash 1 into in means second vertices. 1 to 2 into in means it is second vertices is 2. So the output of my right clipper, right, goes to the input of the third clipper. Okay, right? So in the form of edges, that means 2 dash 3 dash 2 dash 3 dash is one edge, 3 dash 1 3 dash 1 is another edge, 1 2 1 2 is another edge, and 2 cyclic form, 2 2 dash, 2 2 dash, 2 2 dash is another edge, right? So now I'm talking about bottom clipper, right? So come to bottom clipper. This is now the clipping boundary for me. This is the clipping boundary for me now. Okay, right? So if this is the clipping boundary for me, fine, right? So I can see a part of my triangle is towards the outside, right? And a part of it is towards inside the clipping boundary, right? If this is the clipping boundary for me, right? Now let us check how the things will process, right? Now 2 dash, 3 dash, right? So now this is the clipping boundary for me, right? So these things are outside the clipping area and these things are inside the clipping area. Now 2 dash, 3 dash, 2 dash, 3 dash. Okay, right? So 2 dash, 3 dash means it is moving from in to out because this is the clipping boundary for me now. Bottom clipping boundary, right? So all the things below this is outside, all the things above this is inside. So 2 dash, 3 dash means, right, it is going from outside to inside, right? So intersection point I will call it as 2 double dash. From outside to inside means it is the intersection point and second vertex. Sorry, this is inside to outside, right? 2 dash, 3 dash, because these are inside and this is outside, into out. So I will consider the intersection point, that is 2 double dash. Okay, now consider the next edge, 3 dash 1, 3 dash 1. Obviously this is outside, this is inside. Okay, this is outside, this is inside. So 3 dash 1 means both the vertex are outside only, edge is outside only. 3 dash 1, out to out. If it is out to out, what it says, right? Don't consider any vertices. So my vertices is null. Okay, so next is 1 2. Okay, right? So 1 2, 1 2 means it is going from out to in, because this is my clipping boundary. So these all these are inside, all these are outside. So 1 2 in means out to in, out to in means intersection point and second point, right? So next 2 to 2 dash, 2 to 2 dash means obviously in to in, right? So second vertex it is 2 dash. Okay, from this we shall go to the top clipper. For the top clipper, the output of this will be the input of top clipper, right? So that is 2 double dash 1 dash, 2 double dash 1 dash, because for this second none of the vertices we have chosen. So 2 double dash 1 dash, next 1 dash 2, 1 dash 2, next 2 2 dash 2 2 dash, and fourth one 2 dash 2 double dash, 2 dash 2 double dash, right? So above means top clipper means this is my top edge, top window, clipping window edge, right? Above this I don't have anything, right? As above this I don't have anything, right? So all my edges are inside only, correct? Above this is my top boundary, top clipper means, right? Above this clipper I don't have anything, so all this are inside the clipping area. Okay, right? So all this becomes into in means, right? So it will be always the second vertices 1 dash 2 2 dash 2 double dash, that's it, right? So now I have moved through all the clippers, right? And after the last clipper, what is the edges that are there are the output for me. Okay, right? Which are the edges? 1 dash 2 2 dash 2 double dash, that means, right, 1 dash 2 2 2 double dash, only this much, correct? Right? I got this. Only this much is inside the clipping window and all other things are outside the clipping window. Okay, right? This is how I will get. Yes, 1 dash 2 2 dash 2 double dash. This is only the input part that is there and all other things are output. Fine, right? So now this is uh, Sutherland Hedgeman, right? So clipping, polygon clipping algorithm. Fine, right? So first you should be knowing what are the four criterias, right? If my edge is moving from out to in, intersection point and second point. If my edge is moving from in to in, then second vertex. If my edge is moving from in to out, it is intersection point. And if my both the points are out to out, then it is, then I need not have to choose anything here. Okay, right? Then I need this. You can make any combination. First you can go with top, next you can go with bottom, next you can go with right, and next you can go with left, or any combination you can do, right? In the textbook they have given this combination, so I'm doing with this combination. That's it, right? Only thing is, right, you should be knowing correct scenarios how to do. Okay, right? So I have done with left, right, bottom, top, right? Better you follow the same thing, because in the exam they will be in the, for the valuation, right, what reference they will give, they will be giving you this only. Okay, right? Because this is there in your textbook. Fine, right? So first I will consider left clipper, right? That means left clipper means anything outside the left boundary is outside, and within the left boundary means it is inside. Next I will be considering right clipper. Anything outside the right clipper, right boundary will be outside, and all the things, other things will be inside. Next I will be considering the bottom clipper, where anything below this is outside, and all the things above this is inside. Next up, that is top clipper. Anything above this is outside, and below this is inside. Okay, I won't consider any other clippers. Okay, when I'm considering single clipper, left clipper, if I'm considering only left side, I will be checking. That's it, right? Right side, top, bottom, I doesn't come to consideration. Fine, right? This is about polygon Hodgman line clipping. Fine, right? So if you are clear with this, right, I will share the slides of third module. Fine, right? So, and I will be giving you an example object, right? That is the star, right? To solve it. Fine, right? So tomorrow I want everyone of you to follow this procedure, right? And to solve that example and get the right answer. Fine. So I will share that uh, assignment problem, right? So yes, this is your assignment problem. Fine, right? Where this is your clipping window, right? And this star is your object, right? You need to clip the star properly such that only the portion within inside that you should get as the output at last. Okay, right? That means here you have something above the clipper, something towards left, something towards right, something towards bottom also, right? So all the things comes into effect, right? So what is the first thing that you need to do is write all these numberings. Nothing will be there in the exam. They will just give this star and this window. Okay, what you need to do is you need to number the vertices. Each vertices you need to number it, right? 1, this vertices is 2, this vertices is 3, this vertices is 4, 5, 6, 7, 8. You need to number the vertices, and you need to go on checking the intersection of that edge with the clipping window. If there is any intersection, right, you name that with dash. Okay, from 1 to 2 it is going, so I will name this intersection point as 1 dash. Next 2 dash, 2 to 3, 3 to 4, 3 dash, right? Like this you name the intersection points. Then you continue with the left clipper, right clipper, bottom clipper, and top clipper, keeping those 4 points in mind. What to do when it is, when the edge is moving from out to out, or in to out, or out to in, or in to in. Okay, right? So kindly take down this diagram. Okay, right? I will give you 2 minutes, right? You can take down this diagram. Fine, right? So no other things will be given, only this diagram and this clipper will be given. That's it, right? All other things you have to name, what is this intersection points, everything you have to name it. Okay, right? Kindly take down this and do it as an assignment. Okay, this problem is almost they will ask you this problem. Okay, take down this. After that I will be sharing you that slides. That slides itself is the notes. Fine, so you can refer that slide and you can solve this.